Hey guys, welcome to another lecture from ecopoint. Today I want to do a quick brush up on the concept of definiteness and semi-definiteness. Now this concept is extremely important in multivariable calculus. You use it a lot in optimization for maxima, minima, saddle point. So what is definiteness? What is semi-definiteness? First, we always check for definiteness. Definiteness basically stands for strict. Now, strict could be positive, negative. We actually end up applying it on Hessian matrix, but I'm talking about any symmetric matrix right now. So, any symmetric matrix could be positive, definite, or it could be negative definite. What I want to teach you quickly today or brushed up with you is the concept how we check it. The moment the concept of definiteness seeps in, you have to look for something called the leading principal minors. Now, what are leading principal minors? For that concept, we need a matrix for an example. So if, for example, we have a matrix, a symmetric matrix, A11, A12 till A1n, and it goes on till AN1, AN2, ANN. So it's an n variable function that you are looking into. And this is the symmetric matrix A. The leading principal minors are of different orders. So kth order leading principal minor is equal to the determinant of the matrix that ends at A, K, K. How would you get this matrix? If K is somewhere here, A1K, and say AK1 to AKK. So what are you exactly doing here in order to get DK? You are deleting, or basically DK is the determinant of the matrix we form by deleting last n minus k rows and columns. So let's take a smaller example. Suppose we have A11, A12, A13, A21, A22, A23, A31, A32, A33. D1 is the matrix n is equal to 3. D1 is the determinant of the matrix where k is equal to 1. So n minus k is 2. So this means that you will be deleting last two rows and column. Now deleting last two rows and column means these two columns go away, these two rows go away. That means it's the determinant of the matrix that ends at A11. So it's determinant A11. That is basically A11. Now D2. K in D2 is 2. So n minus k is 1. So you will delete last one row or column, right? So last one column, last one row. So therefore, it's the determinant of the matrix that ends at A22. And when it comes to D3, it's very simple because it's a 3 cross 3 matrix. So K is 3, so n minus k becomes 3 minus 3, 0. So you don't delete anything, and it is the determinant of the entire matrix A. So this is how you calculate leading principal minus. In the next lecture, I will tell you how to find out positive, negative. But when it comes to semi-definiteness, it's a weaker condition. So again, it could be positive, semi-definite. It works like less than or equal to, greater than or equal to. So it's a weaker condition. It could be negative semi-definite. We'll talk about that later, but how do we figure out, what do we have to do in order to find out semi-definiteness? What you have to do for semi-definiteness is basically look for all the principal minors. So all principal minors. Now leading principal minor is leading. So it's one for every order. But when it comes to all principal minors, as the name suggests, so you have to consider all principal minors of particular order. All. So there could be multiple minors of a certain order. How do you calculate it? So dk, this time, if I take dk, it's principal minor. It's all principal minor. Principal minor, basically. Kth order, principal minor, not leading principal minor. Kth order, you can write down all principal minor or principal minor, basically. Now, since it's not one, it's not a unique one in nature, so I can't really depict it on the matrix, right? I can't depict it on there'll be multiple. Basically, you should know how to find it out. dk in all principal minor is the determinant of the matrix formed by deleting n minus k rows and corresponding n minus k columns. N minus k rows and corresponding n minus k columns. So what does this mean? In order to understand this, we must take an example here. So I'll again take an example of a 3 cross 3. So A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay. Now, please note down what I have written here. Corresponding is the most important word here. What does this mean? If I'm looking for D1, N is 3, that is fixed. K could differ, N minus K could differ. So in D1, K is equal to 1. So N minus K is 2. So which means I should be deleting 2 columns and corresponding 2 rows, or 2 rows and corresponding 2 columns. So what does it mean? If I have to delete 2 rows, what 2 rows can I take? At the same time, I have to delete 2 rows. I could delete row 1, 2. I could delete row 1, 3. I could delete row 2, 3, right? Now the word corresponding stands for that when you are deleting row 1, 2, you have to delete column 1, 2. When you are deleting row 1, 3, you are deleting column 1, 3. And when you are deleting row 2, 3, you are deleting column 2, 3. And if you are doing that, what's happening? Just think, if you delete row 1, 2 and column 1, 2, what will be left? You'll just be left with A33. If you delete row 1, 3 and column 1, 3, what do you think will be left? Just A22. If you delete row 2, 3, row 2, row 3, and column 2, column 3. What will be left? Just A11 will be left. So your D1 is basically your diagonal. Now the main diagonal. Now you would observe that out of these three, one of them is actually leading principal minor. So in process, when you are actually calculating all, you're looking for definiteness and semi-definiteness, you first check definiteness. And if that doesn't hold, you are not getting any result out of it, you move on to semi-definiteness. Next, D2. Let me teach you D2 as well. D2, K is 2 here. So N minus K becomes 1. K is 2, N minus K is 1. So therefore, you have to delete one row and corresponding one column. Now, if you just have to delete one row, what row could that be? It could be row 1, it could be row 2, it could be a case of row 3. Corresponding means when you're deleting row 1, you're deleting column 1. Row 2, column 2, row 3, column 3. And that's how you get your D2. They will also be multiple in nature because when you delete row 1 and 2, row 1 and column 1, you will fetch the determinant. Just try it out yourself. If this goes off, you'll be left with A22, A23, A32, A33. You won't find 1 anywhere. Similarly, when you delete row 2, column 2, row 2, column 2, you will find the matrix A111, A13, A31, A33. You will not find 2 anywhere. Similarly with R3, that is row 3, and C3, that is column 3, that is just the last row and last column. It will be exactly the same as your leading principal minor. So of course, out of these principal minors, one of them is leading. Leading is unique in nature. And for D3, of course, your N minus K is 0. So that is determinant of the entire, because this is a 3x3 system. So what we have learned today is how to find out definiteness and semi-definiteness. But I haven't yet told you how will you check for positive, negative. That is something I will teach you in the next lecture. Thank you very much.